Okay, you are welcome to Newton class on inverter design, 24-volt inverter design. As said earlier, this is class 2. And in this class, we will be working on the signal amplifier and splitter. The very first thing, these outputs are from the signal, a digital signal generator, which has already been designed. This is the digital signal generator, which has already been designed. So from this signal generator, we are going to take an output from there and design the signal amplifier and splitter. This white probe is the output from the digital signal generator. This is the positive output from the power source, and this is the negative output from the power source. So the very first thing we are going to do is to choose a transistor that will be used for the signal amplification. This is a MOSFET IR2807. This MOSFET has 3 pins. The right pin is the source, the left pin is the gate, and the middle pin is the drain, which in respect to bipolar transistor, this is the collector, emitter, and the base. So I'm going to plug it to the board. And the very first thing we are going to do, we are going to step down the power from the output of the signal generator to the base, which is known as the gate, through a 1K ohms resistor. The reason being that a transistor is designed to operate with a low amount of power at the base. The next thing is to connect the source. Since this is an N-channel MOSFET, we connect the source directly to ground. And the next stage is to extend the emitter. Now, this is a logic system. So at this point, we do not need any reverse charges from any point of the circuit except it is needed. So we introduce a diode allowing only negative charge to flow out of the output of the signal amplifier. For us to know that this circuit is working, we will introduce an LED which will act as an indicator to give us a visual view of the outputs of the signal amplifier. So now the LED is designed to operate on low output power. So what we need to do is to step down the output power of the signal amplifier to the negative pin of the LED. Being that the signal amplifier operates on 24 volts, then the next stage is to connect the positive pin of the LED directly to the positive pin of the power source. At this point, our signal amplifier is ready. Remember, I said in signal amplification, a signal with a lower power output is being mimicked on a signal with a higher power output, or it's being mimicked on a higher power output, either volts or current, or the combination of volts and current. So we are going to power it on to test. Okay, as you can see, the signal amplifier is working. The signal amplifier is working. But how do we then know that it's actually giving us an higher output power? Because an LED can directly be powered by the signal generator. So what we do is to introduce a device which will give us a sound indication of the outputs of the signal amplifier. You know, every digital signal is a sound wave. Every digital signal is a sound wave. and also is capable of generating sound. So we are going to connect an 8 ohm speaker to the output. One pin of the 8 ohm speaker will go directly to the output of the amplifier, and then the other pin will go directly to the positive pin of the power source. You can hear the beep. You can hear the beep. I don't have to leave it for long, so it will burn the speaker. The output power is high and the frequency is low. So what we are going to do is that I'm going to increase the frequency of oscillation of the outputs. As you can see now, the frequency of oscillation is higher than normal. This should be about 47 Hz. So I'm going to connect the speaker again so we hear the sound produced by this type of frequency. You can hear the sound. You can all hear the sound. So without wasting much of your time, you will move to the next stage, which is the splitter.